Hey there, glad to have you here. In today's review, I'm going to analyze the Venlab VM-200M digital multimeter. This is the first Venlab cooperation with the channel, and I'm curious to see how this device will be. Seems small, so it will probably be a good fit for small field toolboxes. But it all depends if it is reliable, so I will check that out in a bit. As usual, let me tell you for disclosure and transparency that Venlab sent this device for review without any costs for me, and I don't receive any payment from Venlab for making this video. I would like to thank Venlab for collaborating with the channel and all of you that use the channel affiliate links. I really appreciate your help supporting the channel. So without further ado, let's see the features highlights. So as usual, I will start by showing you what is delivered and the unboxing. Well, it was delivered in this carton box. Yeah, nothing special really. Let's start and open it. So inside we have the multimeter. It seems small. Also we have a set of lids, test lids. Let's see how they are. Quite plastic, but yes, seems to be flexible enough. Okay, so yeah, they feel like chip, but yeah, this is a chip oscilloscope. It is delivered with some batteries and also a user manual. Let me take it out. So the user manual, what we have here, we have in Deutsch, Français, Espanol, Italiano, and where is English? What the hell? We don't have English manual. I think I saw something in here that should be English. Where is it? Ah, we don't have English. This is the first. Okay, I can read Spanish also, even a little bit of Italian, but this is the first. It says user manual, but read and understand, but where is the English part? Maybe I missed it. Okay, even so, I can read a bit of Spanish. Let's see if I can understand what is in here. We have 2000 counts. Okay. Battery indication. It works 0 to 40 degrees. Okay. Batteries, it's 1.5 AA. So the resolution, we have 200 millivolts, 2 volts, up to 600 volts. Okay, in here I'm talking about DC. If you go to AC, you have 200 volts and 600 volts with a resolution of 0.1 and 1 volt. In terms of current, also you can go up from 200 microamps to 10 amps. Resistance, HVE. So it has a NPN and a PNP detector. Okay. Also diodes, and yeah, that's about it. Okay, let's move this out of the way and let's see how the multimeter is. I will start by opening this package, obviously. This sometimes can be a bit annoying. Okay, take this out of the way. It is small. Okay, we have the usual stand, even so. but in terms of multimeter, it's a small multimeter. Let me compare with my Unity. As you can see, it's pretty small to the on the side of the Unity. So we have only 3 connectors. This seems to work pretty well. It makes a little bit of noise, but yeah, it's very easy to work. Yeah. And yeah, we have the hold light, the knob, and the 3 connectors. Let me start by opening this and putting the batteries in here. Okay, here it is. Let's power this on. It has a very big numbers, so quite nice. We have a backlight also, hold button, and I think that's it. Basically, that's the functions that you have. So let's test this and to see if it is accurate. Okay, so let's start by testing the voltage. I will start by testing this using this reference board. This is the AD584M. It has 2.5, 5 volts, 7.5 and 10 volts. So it's a very nice reference board. Let's start by powering this up. It's like 20 volts, should be okay. So we have 2 decimal houses. Let's power this up and start with the 2.5 volts. So it's right on the mush. Yeah. 5 volts, also very nice. It's over only 1 minor digit, and 10 volts, also 1 minor digit over. So pretty happy with this, yeah. So the next test will be with my millivolt reference board. So yeah, okay, I have my board here already. I designed this board to test millivoltage voltage. This is a resistor divider, and it's pretty easy to create a board like this. You just draw it in a PCB software and just send it to PCBWay. Now is the time to talk about this video sponsor, PCBWay. I always use PCBWay for creating my boards with a professional factory quality, as you saw in my millivolt voltage reference board. It is very cheap to manufacture your PCBs on PCBWay. You can manufacture 10 PCBs for only $5. How awesome is this? And it is pretty easy also. Just insert here the PCB dimensions and you'll have an instant code. So when you want a PCB, visit PCBWay to get your code, and if it is your first time ordering from PCBWay, you can use our access link for a $5 credit. And don't forget, they also have component assembly service, 3D printing service, and much more. Okay, now that we saw how you can have a board like this, I will only take this protection from the test lid, and I will use the common here, and let's start testing. I have to put this in millivolts. So the first one is 10 millivolts. Yeah, 10.6, 10.5. This is quite accurate because it will not be 10 millivolts the real value that we have outputted here. It's always a little bit over the side. So we have 25 millivolts. So it gives 25.1. We have 50 millivolts with 50.1. This one is 100 millivolts. So 1 to the side also, pretty good. We have 500, and for that we have to move this to a higher range. No, sorry, this is 250. So 249. I believe that my Siglent reads 248 here. This is 500. It also passes a bit, but nothing serious. Pretty near. let's see what we have here. This one is 1 volt. This one is a bit below 1 volt, but the value that we get in the board is also below the 1 volt. So the values that we are reading are pretty near the output values. So let me move this again. We have here 2.5 volts. Yeah, again, also pretty good. And this one, I still use this board that has an issue, because not all of the multimeters are able to read 5 volts here. For example, my Siglant is able, the K-Width is able, but my Unity is not, and several other multimeters are not. Let's see what happens here. Yeah, it will not be able to output to read the 5 volts output. I don't know what is the problem here. The value comes directly from this conversion, and yeah, 2.8, and that is also in line with the multimeters that cannot read this voltage as 5 volts do. So pretty nice. Let's move on. Okay, so now it's only missing to test the AC voltage. For that, I have here a cable with live voltage. Very carefully, don't forget this will kill you if you do something wrong. Insert this on the first hole and the other one on the second. Yeah, like this. And the voltage that we have is 237. Okay, this normally oscillates between 230 and 214. So right now this is on the middle, so yeah, pretty nice, accurate also. Okay, let's move on. Now it's the time to test the resistance. I have here in this board also capacitance, but this device will not read capacitance. Okay, so let's start with 10 ohms. 10 ohms, pretty nice, really on the mush. And the reference value it's exactly 10 ohms. We have here 100 ohms. So this one is a bit below. We have 100.03s in the reference boards. And okay, we have to change this to 2K. 1K, also below. Let's move again. This is 9K, 9.96. Yeah, it's really near. And let's move this to again 100K. Okay, 99.8. I will bring my faithful Unity to see what values we have with him. Okay, using the same probes. Let's see if the values are near or not. Okay, let's start with 10. 10.21. It's over. 100 it's near, so I have 100.03, but this is a little over. So next 1K. For 1K we have 998. It's a bit below, not much. So now it's 9K. 9.98. It's also very near the values we got on Venlab, and the final one it's 100K, and we have 99.98. 99. So the reference value is 100.06. So yeah, this is really near the reference values. I would like to test also with this board. Normally I will connect something here and we'll try to change several values. Today I will do something different. I will measure directly the resistance that we have here. So for that, let's start with the, I think it's 0.1 ohm. Let's see what we get. Okay, I think this is too low. Okay, and this one 0.2, yeah, 0.1. Okay, almost there, but even so, I felt this is not even 1 ohm, it's 0.1. Yeah, in this one, maybe because we don't have enough enough digits in there, the resolution is not enough. So in 1 ohm we have 0.8. in this side, let's try in the bottom, 0.9. okay, we have also 10 ohms. Let's see, 10 ohms exactly. Nice. And in the bottom also 10 ohms. Very nice. The next one, it's 100 ohms. Let me see if I can get it. 99.4. Let me see one on the bottom. 99.4 also. Let's see now 1K. 1K, I have to change this. 99. So we have 99.5. Okay, on the top, what we get? 99.5 also. I didn't said before, but this is 1% half watt resistance. It doesn't say the ppm, but even so. Okay, now let's say 10K. 9.95, sorry, and this one 9.96. okay, pretty good. I was in 10K, so let's move to 100K. Let's start by the bottom. 99.7. On the top, what we get? Well, let me see. 99.7. And for last, we have 1 mega ohm, and for that we have 99.9. it's one digit to below, and the other one exactly the same value. So yeah, pretty neat the results I have in here. Okay, let's move on. Okay, in terms of continuity, let's test it. It seems pretty fast to respond. You have also a visual signal there. As you can see, it has a very high sound. Okay, let's see how it handles a diode, like this. Okay, 1.77, so this is a 1.8 diode, LEDs. Okay, very nice. I have here one that I don't have any idea, it was disassembled from somewhere, what it is. So it is a 1.7, 1.8 diode also. Very nice. I have here a diode, I hope, yeah. I think it's the other way around, but yeah. Okay. Seems nice also. Okay, so let's open this and see how it is in the inside. So now it's teardown time. Okay, so we have this plastic like rubber cover. I didn't notice at first. In terms of the board, nothing special going on here. We have here the main processor, the beeper, the fuse, connectors. Yeah, I will not even bother to take this out to see the rotating knob base. So yeah, I was not expecting nothing much. We have some connectors here, as you can see, and a place for a capacitor. Yeah, this is from 2022, April, 1 year ago, this board. So yeah, nothing special going on here. So yeah, let's move on. Okay, we are back. Let's see if it's working. Seems so. Let's wrap this up. And I don't know if you'd noticed, but there is a category of digital multimeters under 10 euros or roughly $11 in AliExpress that don't have capacitance measurement. This Venlab VM-200M is in that category. In terms of prices, on the high end of the category, costing around $11 on the Venlab official store. The shell is all plastic but seems resistant, and stuff I personally didn't do a drop test, seems to survive if you accidentally drop it. This will be a perfect addition to a field toolbox bag since the size is small and it is quite compact. You have also a backlight that really helps on a darker environment. It is really accurate, especially on voltage measurement. Also, resistance measurement was really near the reference values. Considering the price and what you get, it is a nice option in that range. But let me be clear here, there are also other options in the market with the same features for a more attractive price. This one I tested and seemed very nice and accurate. Can talk on the other option. I think this is a first for me, but for me personally, this digital multimeter will not be an option. I prefer to spend a few more bucks and buy the VM-200M, also from Venlab, that has a lot more options like capacitance measurement, non-contact voltage detection, hertz measurement, and so on. So every case is a different case, and if for you this is perfect, then you will be okay with this device. As usual, if you are on the market for buying a digital multimeter like this one, why not help me support the channel and use the affiliate link in the description or one of the channel affiliate access links here in the screen. You won't pay any more for your purchases and you will help me with the channel. So thank you very much for your help. It's really appreciated. That's all for today. Thank you for being here with me and I hope to have you also in my next video. Until then, stay safe and Godspeed.